Hey everybody, Jason here. I hope you're all doing really good. Today I'm working on an iPhone 7. Did I hit record? Oh, what a life I live. Today I'm working on an iPhone 7 that was sent here because it would not update or restore. I don't recall exactly what the iTunes error was, but in 3U Tools I can tell you it hung up at the point where it was unmounting file system. So I think this one is going to wind up being a NAND fault. Now I have the NAND already off of this board. So here is our customer's board. On this board, I removed the NAND and I put it in the reader, and I was able to read the sysconfig data off of it. So I have that saved on my desktop as basically a bin file that we're going to turn around and write to a replacement NAND and put it back on here. So when it comes to these NANDs, the iPhone, I don't know what it is, but it seems like the iPhone 7 and 7 Plus have been really, really bad about these things just dying for no reason. Now, when it comes to NANDs, I have found it to be more cost effective to actually buy iCloud locked boards and pull the NAND from them than it is to buy the NANDs. So primarily my source for these is iCloud locked boards. It works great. I know it's most likely going to be a good chip, so let's move on with this. I'm going to put this in a board holder and we're going to remove the NAND from this board. I'm going to clean it up and we're going to reprogram it for this customer. And in doing that, I'll get to show you how the little programming module thing I have works, and also how I remove this little pain in the ass. Let's see what we got. Here is our donor board, which I have confirmed that it boots. I have confirmed that it has a 128 gig NAND that is fully functional. We're going to stick this in our holder. There you go. I want it to get, it needs to be clamped pretty good and tight because we're going to be putting some pressure on it. Now, let's get you under the microscope. Ugh, looks a little funky. We're just going to ignore that, right? All right, I've got my hot air set to 250C, and I'm going to use our beloved little hooker. Yeah, that's my hooker. And let's start warming this steaming pile up. I noticed that I see, is this CPU-age? I thought I seen some of the little beads that hide out under the CPU shield laying there. Okay, now on iPhone 7 and 7 Plus NAND, I start down here at the bottom right. This is also going to be where our marker is. And I start down here because I can start here, end here, and pull the IC here, and I'm going to show you what I mean. Now, although this is just a donor board, I'm still going to be fairly careful because I like, I'm always trying to practice and always trying to improve, but I'm also trying to save time too, so we're not going to waste a ton of time on this one. So basically what we do with these is we just carve it out. Sometimes I'm a little more picky than others. It just really depends on my mood. So this glue can be a real pain in the ass to work with, but by heating the board up and holding the board hot, as you can see, I'm pretty well just carving around this. Now, I don't think you see this exactly as I see it. I think the camera that you're looking through is actually hooked to my left, the left side of this. Whoops, see there, I knocked a component off. Fucker, get out of my way. The camera is shining from, it's pointing from the left side. So, oh boy, son's calling me at school. This ought to be good. Hello? Oh boy. Teenagers. All right, where was I at? Microscope. Yes, microscope. And now the board's cooled down a little bit. Okay, so we pretty well carved down this one side here. Let's get our hot air going again. Now, I have done this with a preheater as well, although the preheaters that I have, they just don't hold tight enough. I use quite a bit of pressure carving these things out, and I don't want the board sliding around and stuff. This board holder here that I got from Union Repair works fantastic. And when I first got it, I was like, oh, who's ever going to use all this iPhone X stuff, and look at all this crap. And I took a bunch of the clamps and, holders and, things off of it to make it easier to use for the models that I was servicing. But I tell you what, it didn't take me long to start servicing the iPhone X and being thankful that this board holder has slots and things to hold things. And we like holding things. Okay. Now I do have to get this done in a reasonable amount of time. So I'm just going to go ahead, I'm going to cut to the chase here, and we're only going to be slotting this around the chip. Now, on the customer side of this, on my live board, I sit here and I trim around a lot of these components because I don't like solder balls to squeeze. But since this one is just going to be a pull the chip, program it, and use it on another board, I am going to go ahead and just cut our slot. So I trim around the chip all the way around. We've now done two sides. Now this side has a bunch of 1005s all along it. So I usually heat this up and like make a cut right across the top of all those. And try not to catch them and yank them off the board. And then I line up straight and go vertical and cut down beside them. And a lot of times I can just, really knock these things out. I think I can do a NAND repair from start to finish, a memory upgrade from start to finish in less than a half an hour. Or right at about a half an hour, 20 minutes to a half hour, something like this. This stuff used to be something I was afraid of, working with underfilled components. But as time goes on and Apple gets more and more douchey with what they try to do to keep things from breaking, I've gotten more and more used to dealing with underfill. And it's amazing how you can make stuff like this a routine task after you've sit and beat your head against the wall for weeks on end. All right, let's go ahead and make a little slice. Uh-oh, I've slipped out of donor board mode. I'm in customer board mode. I sit here and I'm ridiculous. I sit here and clean this stuff up, but I like to put it all together and then just have the damn thing work and not have to deal with finding shorts. And this is a process that I have become very fond of, and I'm thinking we may... No, I'm not thinking anything. I'm not going to say that out loud. You know what happens when I say things out loud that I'm planning on doing? Two things happen. One thing is that I have trouble following through with it, and the second thing is other people take the idea and run with it and like produce these awesome videos, and it's like I'm sitting there having given out a really good idea. Okay, so we have the NAND now cut all the way around, and remember I said that I like to start and stop in the same place? See, we started right here about where pin 1 is. And we cut all the way around, and we stopped right back here where pin 1 is, and conveniently enough, there is a gap in the components right here. See there? There's a big gap right here that allows me to slide in my hooker. Oh boy, my nerves have been shot lately. I'm having trouble showing you this. So I'm going to slide the blade in this way. And you see how we can get that blade in there and still not touch any components? So we can actually slide that in and pick it right up. So let's turn the hot air up. Now it is important to use a fairly large nozzle on this. I'm not sure which nozzle I'm using here. I'll tell you what I'll do. While the hot air is running, I'm going to do the responsible thing. And I'm going to grab a wooden ruler. Wait, that don't have millimeters. Maybe I shouldn't do this with the hot air running. All right, let's do the even more responsible thing. Let's use a plastic ruler. Let's try not to get it in the, so that's 1, 5, 6, 7. This is 7 or 8 millimeters, I believe. Might be wrong. All right, let's pull this chip off of here and get this phone fixed. I believe this one was one that was hanging at unmounting file system. I know I marked a big old NAND on it and threw it aside because I didn't have any more. It's amazing how fast you go through these things when you start working on the iPhone 7 and 7 Plus. Maybe it's where they bend. You know, they're not all that different from the iPhone 6s. I'm starting to get a little bit distracted here. All right, fellas, we're going to keep heating this up. I'm going to get my blade ready down here. And I'm going to feel for first the adhesive to start to soften, which is going to allow me to insert my tool. Okay, we're now up against ballage. Now I'm going to heat this up. Now when the solder starts to melt, I'll be able to push this tool in. Ooh, look at that flux coming out, boy. Okay, here we go. I actually love this repair. A repair I was scared of for so long. Alright, I see solder all over the place melting. We're good now. Pop it right off there. Okay, now I'm going to do something really stupid. I know this is just our donor board that we're looking at, but I'm going to show you real quickly how I clean up the pads. To do that, I'm going to take some leaded solder wire. Gosh, I popped, balls all. See, this is why I clean out around all these components, because I don't like solder balls swelling. So, to clean this area up for a new chip, what I like to do is I take and I flood all the pads with leaded. This must have been a physical impact board. We're actually missing some pads, and I hardly ever pull pads on NAND. I didn't really look at it real good, but yeah, this sucker has definitely got some issues. So once I flood it with leaded, I'm going to take and just, we take and sweep the leaded off of here. Flooding with leaded, that does a couple of things. It lowers the melting point of what's here. It makes it easier for me to mop up this crap. But also, you'll see during this next process, it's going to help me. And let's wipe this off with alcohol so you can see what's happening. Having the switch to leaded is going to help me with this next process because our melting points are lowered and our pads are flatter. Okay, now this board, it still has a whole bunch of funky ass underfill right here. There's a whole layer of it, and that stuff can't stay. So what I do to get rid of that, I will actually often heat the board up to the point of melting leaded solder, and I use this little hockey puck that I got from Union Repair. I love this tool. When I first got it, I was like, yeah, I'll never use that stuff, I'll just get me an X-Acto blade. Well, I'm here to tell you, watch this. Are we in focus, like good enough to where you can see? If I tried to do this with an X-Acto blade, I would drive myself insane. Like, watch what we can do with this blade. It's designed to do this. Like, it's designed to literally squeegee, or whatever you want to call it, utility knife, putty away, like, that layer of crap. I mean, look at it. It comes off in big hunks. Like, you can literally fly through this and remove this underfill, like squeegee it right off there, like whoop. Now, when I started doing these, I'm burning my hand. Ow! Ow! When I started doing these, I took a long time to figure this out. And I don't remember who it was I watched on YouTube. I watched somebody on YouTube using this tool. And man, this is the tool. And the reason why I heat it up to the point of melting leaded is because, let's see, right over here, here's a good example. Sometimes you'll still have a hump. There'll be a solder left on the pad, and this tool will take it all. Like, watch, see if I can get the angle right. Not getting the angle right, because I'm not turning it. Okay. I'm getting caught up in the video aspect of this, and I'm just, I'm doing this on my own. I mean, look at here, we just fly through it. Okay, so we'll turn it again. When I'm recording, I'm not turning as often as I should, and there's all this crap that holds me back. And when the bill's got to be paid, it's very difficult. Let's see, can you see that glob up there? Okay, here's the glob. Now we're going to take that off of there. We're going to take all the rubbery coating and the leaded solder. And we can actually just, where there's solder left, you can just right off of there. So I'm going to go ahead and stop right here on this one, because this is just our donor board. But, I mean, as you can see, in just a few minutes, we've cleaned this thing up, like way up. We've cleaned it up enough to put a chip back on it. So, you know, this repair went from taking ages and being all intimidating to being like, you can literally fly through it. All right, now, we're not here to watch me play with a board, right? I was going to say play with myself, but I'm not really playing with myself. I'm playing with my board holder and my my hooker and my bent tool. Let's put this aside. This is our donor board. We're no longer going to need that. Okay, now here is what I mean whenever I say that I'm glad that this board holder has all this crap. Let's see. Let's clean this out a little bit. It's like I got some nasty old alcohol or something in there that dried with a bunch of residue. All right. So our board holder here, it has a spot that is made to hold this chip. Makes it very handy. It slides right in there and holds it. So we'll kick that aside now. And we're going to put that under the microscope. Now, basically, same thing. We're going to flood with leaded. We're going to use our cool little hockey puck to clean off this chip. And then we're going to get down to the fun business where we can actually reprogram the chip. Flood with leaded, flood with leaded. Try to get all of our lifted pads off of there. Yeah. Looking good. Actually doesn't look like there's much underfill left on it. I like it when the underfill stays on like one side or the other, especially whenever it's the side that I don't care about. Wicked. Oh, my nerves. Wicked good. My anxiety has been off the charts lately, guys. I apologize for not uploading and posting to YouTube as often as I would like to. You know, somebody said to me, they were like, you seem to place, you know, in my meltdown video about, you know, being social and stuff, somebody made a comment about you seem to place value on being able to socialize. And that actually made me think about it for a little bit, because I actually do. And it made me think, well, what is the actual value in that? And truth be told, I think there's a lot of value in that. There's more value for somebody who's trying to be a YouTuber, but just to be able to speak up in life and, you know, ask for things that you need or want, or ask for help in certain situations and stuff. And then, I don't know, I think the type of person that would make that comment does not understand what it's like to be the one at the party that nobody's hanging out with, and be the one that has to, you know, watch the cool guys that know how to roll, get the chicks, you know. That was the story of my life going through school and high school and stuff. It's just, you know, I never went to school dances. I always kept to myself. I knew better. You put me in a crowd of people, and I made everybody feel awkward. Looks like I nicked that chip a little bit right there. We're going to just go ahead and ignore that for now. So yes, the grass is always greener on the other side, and I place value on the ability to socialize. Which, you know, I'm not that bad off. Like, don't get me wrong. I hang out with friends and people here in Florida, and we all have a good time, but you know, there's often times when I want to get stuff off my chest, and it's like, it's frustrating because, you know, I want to talk about it so bad, but I just, you know, I can't. I'm like or not physically, but I'm just mentally not capable of it sometimes. I'd like to rant quite a lot right now about Google killing ads that have the word iPhone in them, for fuck's sake. And you know, they didn't say it was iPhone. Like, it says that it's something about like third-party tech support or something. Alright, so this is looking pretty good. We've got a tiny little bit of adhesive over here, but I'm going to leave it. Yeah, so it makes me mad. I feel like there's a lot of political, like Apple's really, really pushing on Google. let's not talk about all that right now. There we go. Look at me, I'm sitting cross-legged in my work chair. I'm all comfortable. So here is our cleaned up, hopefully a 128 gigabyte NAND. Now what I'm going to do with this is I'm going to take my beloved programmer, which I love so much that I keep putting it back in its retail packaging, and let's make it so you can see my hands. All right, so here we are. I did a video recently on the JC programmer. I'm going to actually, let's see, for the sake of the video, let's throw that out there first. Now, I'm not actually going to use this for the job, but I am going to show you what it looks like. Okay, so here is the programmer, and if we connect our NAND thingy to it, it automatically pops up with the application for NAND. And we're going to put this in here and hope that it is 128 gig. 3U Tools said that that phone was 128 gig, so let's see. It says HDD is detected. Should read really fast. If they get to the end and hang up or just sit here beeping and crap, then it's no good. Okay, so you can see that is a 128 gig chip. Now, if you want to, we can do read write. We can do extract. And there, it's got, you know, the MAC address and everything. We can also do save and do extract. And basically what we're doing is we're saving the serial number, the Wi-Fi MAC address, the Bluetooth MAC address. That's the information that we're saving. Although these NANDs do have, you know, several partitions, I don't know what contains the user data, and I don't see any option to be able to access the user data. Okay, so let's not get our chips confused here and write the wrong data. This chip that I just read and wrote, that is the donor chip. Now, let's go ahead and get this hooked to a computer because I feel a lot more comfortable doing it that way. And I can also, I think I can show you more better, more awesome, more better. All right, so let's hook our little cover thing on there. Now to hook this to the computer, we are going to use, I'm going to use JC's proprietary application. And here you'll be able to see that on the screen. If I put this off to which side? Let's move you over. Let's put you over here in all this dirt. Okay, so with the JC thing on the screen, we're going to select NAND repair. Okay, and right now it's only showing that I got 2 COM ports. This one's going to show up as COM 4. You can see it automatically switched to COM 4 here, and we're going to do open port. So now we've got the port opened. I'm going to go ahead, I'm going to make a backup copy of this chip, just in case the board in question, for whatever reason, ever becomes un-iCloud locked. Whoa. Okay, so here we've got the chip in the NAND that I'm going, or in the reader that I'm going to be backing up. So I'm going to click Backup Sysconfig Data, and it's going to pop up and ask me for a file name, and it automatically names it. I don't have a name to put on that one, so I'm just going to hit save. So there, we have backed up this chip, and I've actually already read the data from the other chip. Let's go ahead and do it anyway for the sake of this video. So here is my customer's 128 gig chip. Now, this chip, although this chip reads, fuck me, what the hell? It reads, it reads really, really, really slow, like, I don't know, it was like 20 or 30 megabytes a second. This utility says that it passes, but it don't really pass. I wouldn't be surprised to see it not read today. Okay, so now we're going to back up sysconfig data. This is my customer's. So what I'm going to do, I'm going to stick a job ID on that file. There we go. Now that we've backed up our customer's chip, throw it aside. Now we're going to take our donor chip. We're going to wait for this to load in, and as soon as it does, I'm going to take and I'm going to format it. We're going to format sysconfig. Now, once you've formatted sysconfig, you'll see if we query info, this sucker comes blank. It don't have a serial number, it don't have a color. So now we're going to restore sysconfig data. There we go. So we're going to pick the file that we saved, and we're going to hit OK or open or whatever. Now that just restored that data to this NAND. Now we're not talking customer data. query info. We're only talking about basically the serial number, mode, area, the color. You know, there's a model number here. There's a lot of different details here, but in order to get through activation, in order to have this thing pass through a restore, we have to have this data here. So now we have reprogrammed this data here. Let's, you know, we're already here. Let's unlock Wi-Fi. That's it. Wi-Fi has been repaired. Now this phone has the ability to have the Wi-Fi chip switched. Isn't that crazy? Okay, so now we're going to take that chip out of the reader. Old chip over here, tell you what. And you know, this chip might actually work after a format. I didn't even try it. I've just got to where on the iPhone 7, if it's a NAND problem, I swap it. Like almost every time I've ever tried to just like format it, reball it, put it back on, it winds up ending in a situation where I'm just doing it. I'm just swapping it anyways. All right, since I love my beloved thingy, I always put it back in here because it was expensive. Do the same thing with my eye socket and stuff. Here's our customer's board, but we're not going to need that yet because this needs some brand spanking new balls on it. Let's go ahead and switch this over here to reballing station B. Here we are at reballing station B, and I need a napkin. Crap. Now, these, thanks to YouTube and all of the people, the wonderful people that I follow on YouTube, I do a reballing on a napkin. It seems to work really, really, really well. Let's see if Jason can pull this off today with far less than perfect nerves. Now, I'm going to reduce my hot air here. I normally operate around 400, 430 on the iPhone 7 boards, but since we're going to do a leaded reball, I'm going to drop this down in maybe in the high 200s, maybe 300. Now, I haven't calibrated this station, so your idea for what my temperature is probably like a lot different. You know, this is being set just by how I see things behave, because I really don't know what temperature my hot air is. All right, so this is a pretty shallow stencil. It's not going to put any gigantic balls on here. I should be using dry paste for this because it works a lot easier, but I don't have any without drying some or using some old crusted up funk from an old blade. So we're going to be putting wet paste on here, and then I'm going to sort of dry it with hot air, and I'll show you what I mean by that. So we're just going to fill in these holes all, pretty nice and even. There we are. Let's see if I can hold that and show you around. So basically, I just filled its holes and wiped it real quickly with a blade. And I'm using these, I use plastic blades for this. Okay. I'm going to hold that chip down right about there. And we're going to start warming up the entire area. Now, when I said that I was going to dry the flux, you will see here as I warm this up that the flux sort of goes away. I don't know if you'll see that or not because my camera's not very good quality, but the flux will run under the stencil and it leaves us with dry solder beads. See how dry that is? Now, that might get wet right as it melts, but I literally watch the flux run away under this, like run away or, maybe evaporate away or something. All right, here we go. Trying to do this fairly even because I don't want the stencil to warp. Oh, this is lovely. It's just marvelous. I love reballing stuff. Remember when you used to watch this channel and you used to hear me whine about reballing all the time? I don't whine about reballing stuff anymore. It's so cool. Now, a couple of these did wind up a little dingy. We're not going to sweat that too much. All right, now let's hold this chip here. I'm going to give it one last little float. There we go. Now, this next step is to prevent me from doing things twice. I'm going to go ahead and clean this off. And I know I already put the reader away, but I just want to make sure that this still reads after reballing it. I have done this process before and wound up with a chip that would no longer read. Or write. Or format. Sometimes they'll read and won't format. And these things, they develop there's some weird issues that go on here. Now that we've got that chip cleaned off, I'm not going to get a bunch of flux inside of this Dooley Moohickey here. And let's have a look at this through JC. Let's get it connected. Okay. And all we're looking to do here is we want to make sure that this thing still reads data. And it does. It read, filled everything in, so we're good. We're going to take that back out. This is ready to be soldered on. It has brand spanking new leaded balls, non-hairy, mostly non-hairy, and it's ready to see a board. Here we have the customer's board in the holder. It's all cleaned up already. It's ready for the chip. We're going to put this under the microscope and solder down the chip. It's just beautiful. All right, I see a little bit of a scratchy down here. We're not going to worry about that. Just making sure we don't have any glue or anything that's going to create any barriers. All right, guys, we're ready. Now, I'm going to crank my air back up to 430C. I'm going to start heating this board up, and we're going to add some flux. A baby amount, because I don't want to have to, do a bunch of cleaning. I do these without even pulling the stickers off. It's like, when it's a NAND, it's a NAND. There are some things that really screwed me up though, man, like locking up during writing file system at a specific percentage. Who would have thought that that's not NAND? Like, holy crap. I'm sure there's some instances where it could be NAND. All right. We're gonna get this fairly lined up here. Now, since we got huge ball spacing and huge balls, this don't have to be anywhere near perfect. We're just about good right there. Okay. So I'll get you up there. That way you can see. Or maybe, no. Let's do it here. We're waiting on the leaded solder to melt. And we'll see this chip settle when it does. Okay, I see flux starting to bubble. I see the chip starting to settle. We're going to give it a baby nudge. Here we go. So now we have just soldered the NAND on there. And I'm going to wait to do any cleaning on this to make sure that this thing works. So let's take it out of the board holder, like so. We're going to drop it into a customer's housing. Oh no, I just put an iPhone 7 and an iPhone 7 Plus. I was so excited the first time I transplanted NAND from the 6S to the 7. Oh, this board is so hot I can barely touch it. There we are. Now for this little experiment, I'm going to want the power baton flex. We're going to go ahead and hook up the customer's screen assembly. Looks like I actually did that without crinkling the stickers too bad. Must be getting better. There we go. Ugh, man, that sounds horrible when that happens. I wonder how our battery's doing. Let's see if we can... I don't like reboots due to crappy battery data. So let's see how the battery is. You know what? We won't know because it's going to go straight to DFU mode. Yeah, we're not doing this on battery, guys. I don't want to. We don't have to worry about those reboots until after the restore. So let's get this on DC power supply. That way we know, if we're started up in DFU mode, we need to know what the current draw is. I'm going to put the power supply on the screen. Now, I'm going to connect our iPhone 7 lead to the battery rail. I can see we do have some adhesive over it. I'll have to clean that up. Okay, and we're pulling 10 milliamps. This is acceptable. Sometimes 10 milliamps actually comes from the cable itself. No, it's coming from the phone. Could be any component here in the phone. I'll have to check that after cleaning and stuff too. Okay, so we're drawing 10 milliamps before button press. We're going to press the power button in 1, 2, 3. I'm expecting a blank screen with backlight. Okay, we stalled at 80 milliamps. That is what we would expect. Do we have backlight on? I can't really tell, but I would expect this phone to stall at 80 milliamps because it does not, it's not ready to boot. So for this next process, I'm going to kick iTunes up on. Oh boy, iTunes is going to have to download. Okay, well then, since iTunes is downloading, I'm going to go ahead, I'm going to stop the video, and I'm going to come back to this whenever this thing has a progress bar, so be right back. This is like waiting the last 5 minutes for school to be out. You know, you're sitting in your last class for the day. It's been a long time, but I remember what that was like, and you're sitting there watching it tick, tick. That last 5 minutes of the day, it was awful. Keep an eye down here on iTunes. Here we go, extracting software. I don't remember where this one was hanging up on iTunes. I know it would just flat out hang up and it would sit there forever. And it would do the same thing on 3utools, only on 3utools it was hanging up where it would say unmounting file system. That's where this one was hanging up. I'm about 95% sure that this one is a NAND issue, and if it is a NAND issue, then this restore is going to complete without a hitch, and this phone will be fine. I like doing these repairs whenever the actual repair ends in a upgraded storage. Like the one I did not yesterday but the day before, it came in as a 32 gigabyte phone and it left here as a 256 gigabyte phone. And that was a random donor board. I grabbed one out of the pile. I'm like, ooh, that looks like a good NAND. 256 gig. Golly, lucky customer. He was grateful. Okay, you don't want to see me mouthing. You're going to want to see my hands. Okay. So here's what that phone looks like. I'm going to also add iTunes to the screen so that you can see what iTunes looks like. So you should have the phone here and iTunes. And if I move this just a little bit too far, it's going to disconnect. Like I got, you know, my USB cable's not the best in the world, but these power supply leads pop off really easy. Okay, so we've passed verifying restore with Apple. That's good. And we are restoring iPhone software. This is most likely going to be successful. I mean, most NAND symptoms, I don't know what I'm talking about. Don't listen to me. Some symptoms are clear-cut NAND. I started to say that some of these symptoms are just obvious, but they're not. You got, let's see, you got FDR trust data, you know, that winds up being NAND. You got writing S3E firmware, that winds up being NAND. Like, who would think FDR trust or S3E firmware was NAND? It sounds like something that's being written onto another IC somewhere, but no, FDR trust and S3E firmware, they're NAND failure. I'm sure there's probably occasions where they're not. Okay, so where are we at here? We're at restoring iPhone, and here's what the iPhone looks like. You can see that we've, so maybe I can move, I'm trying to get that glare off the progress bar without moving the phone. There we go. Now, I'm not for sure if the unmounting file system would have been after this restoring software. I'm not really sure about that, but this has been on the shelf for, I guess 3 or 4 days since I realized that it was going to be NAND. So, and I didn't make a real clear note. I just wrote NAND on the ticket and moved on. All right, we're looking good here, verifying iPhone software. I can tell you what I think is going to happen here. I think we're going to make it up to a point where this phone is going to need iCloud credentials, and then I'm going to have to stop and talk to the customer. Okay, verifying software. I think we're getting ready to get a successful message out of iTunes. And then the phone's going to finish doing its own thing here. Come on, baby. Please don't lock up at verifying iPhone restore. Oh, for the love of God. Did this thing lock up verifying iPhone restore? I'm a lot more optimistic than that. It's going to go past it. Dun 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 dun. Use steaming pile of thank you. Thank you very much. Thank you for thank you for passing that, mofo. All right, restoring iPhone firmware. I believe at this point in time is where it is maybe updating some baseband stuff in Stockholm, which if we were using 3U tools, we would actually see those things scrolling across the screen. I have big time problems capturing 3U tools though, so I'd much rather do this with iTunes whenever I'm recording a video. Come on, baby. Yeah. Just sit here, sit back, live off the fat of the land here. Come on, piece of crap. I need your money. Come on. Pass this restore so that I can bill this customer, so that I can pay for things. Although I am very optimistic, and I'm very optimistic because this is a process that I've been through quite a few times now, I'm always ready for the iPhone 7 to throw me a curveball, or 7 Plus, whatever. I'm ready for it to throw me a curveball. Restoring iPhone firmware. This is normally what, like 80% on 3U tools? You know, it can take a while, so I'm not ready to give up on this yet. Not yet. I'm not giving up on it yet. iPhone firmware. Who gives a shit about Stockholm? Nobody even really uses baseband, right, Apple? That's why iPhone 7 and 7 Plus don't really need it. I can't believe that everybody's Google ads are getting shit canned. I gotta find something to talk about. Mine got shit canned for having the word iPhone. Again, like, it's been almost a year. I got shit canned almost a year ago for having iPhone in my Google ad. And I changed it around a little bit. Didn't work. So I deleted it and made a new one with the word iPhone in it. And it approved, and it's been running for like a year. And then recently, it's got a red line that says your ad's not running. Only this time it says that, I'm not going to go into details, but it basically eludes me. It's got a phrase there that says that... Did I leave it open? I didn't. Okay. Anyways, it made me think that it is due to me being third-party tech support rather than a repair tech. And it's like, I don't know. Is it because my ad had the word Apple in it? Or had the word iPhone in it? I mean, that's like, how far is Apple willing to go? For the longest time, I've been feeling like a lot of these Apple bashers are just Apple bashers. But when you see them doing things to hide the fact that things can be repaired, and I've heard that they are actually leaning on Google, like putting pressure on Google to fix policies and things to take away people that are advertising iPhone repairs. Now, I don't know if that's all true, but is this done yet? That would sure change my stance as to how I feel about their business tactics, because that would just be absolutely crooked. Not only lie to customers and say, you can't get your data, lie to them and say, this can't be fixed, but then make it so that one of the biggest search giant in the whole entire world begins to like tuck that sort of thing under the rug, where people are saying, I can fix it. They're just not even showing them. All right, this son of a bitch is still restoring firmware. Now, don't quote me word for word on all that, because I'm just a micro soldering tech. I haven't spent time reading news. I haven't, I logged into my ads this morning because I noticed that, it was like an immediate drop. So I logged in and seen what was going on with the Google ad. This son of a bitch is still restoring firmware. And sure enough, the ad wasn't running, and it was due to, it wasn't due to a trademark violation. It's due to, it had the word other in it, like other business, and you click on it and it takes you to a page that describes where third-party tech support isn't going to be allowed to run ads anymore. Like, are you serious? That's out there, man. It's way out there. I just don't see how that would have got me flagged for the word iPhone. And if I did get flagged for the word iPhone, why didn't I get a trade violation? Man, I'm starting to get really nervous. I'll probably edit past all this. I wasn't planning on doing a bunch of talking here. But, it's still going. Okay, we're verifying phone restore. And as you can see the progress bar now, it's now made another jump, and we're going. Yeah, if you know more about the Google ad censoring thing, I'm sure it's not that complicated, but feel free to leave it in the comments below. I will eventually get to a point where I go and Google it myself. I never really... Okay, so we've got a successful restore. The phone is rebooting. It's been a long time since I've leaned on advertising, but as I've gotten to be more and more, frustrated with prior attempts and stuff, filtered repairs to where everything that comes in is a convoluted mess, I have started to, lean a little bit more to advertising and trying to drum up alternate customers outside of YouTube. Now this should be this phone's final progress bar. I think after this, we're going to wind up at a setup screen. I'm going to go ahead, let's see, we'll leave iTunes on the screen there just so you can see it whenever it connects. Okay, we have an iTunes Connect. Oh, 3U just hogged up the screen. iPhone, welcome to your brand new iPhone. Come on, baby. What do you think the odds of this not being iCloud locked are? Slim to nothing. Another one of those things Apple did to really boost the reuse of old products. They want you to buy stuff. These phones, these Apple phones, they are iCloud locked. See, these phones are abso-freaking-lutely engineered to fail. Have a look at the iPhone 6 touch failures. It started with, the pad separating under the Mason IC chip, and it's so bad that some of the pads actually come away from the board. And then on the same exact phone, you got searching no service on the other end of the board, all due to this flexi board design. And so you got searching no service, you got touch failure. Then you wound up with, there's a subset of CPU failures, some of them that people are fixing by grinding into the CPUs, and all of these failures that are only going to get worse. And what does Apple do? They add 500 more solder joints. What the fuck? This is engineered to fail. Yeah, okay. You're going to tell me that this design's stronger, right? This PCB design's stronger, right? Yeah, it is. But are we supposed to be strengthening the housing with the PCB? Is the right thing to do to strengthen the PCB to prevent the housing from bending? I'm sure that they're also strengthening the housing, but something changed between the iPhone 5S and the iPhone 6. Although we did have, and I didn't do a lot of board work around the iPhone 5S, but although we did have, some of the same sorts of problems, it wasn't rampant. It wasn't widespread. And now it's gotten to the point where it's just like, people accept it. Apple's like, yeah, we're making this shit the break. It's only going to last you a couple of years, but here's the newest model. All right, so this phone, I bumped that damn power cord. No, it's a battery reboot. All right, so this phone has made it up to activation. I'm going to go ahead, I'm going to connect a battery to it, and I'm going to get it on the charger, which now we should see a battery charging. No, we're going to get an Apple logo. Oh, that's right, it booted to DFU last time. Okay, so let's get iTunes off the screen so that you can see the phone. It was in DFU the last time, that's why the screen was blank. Okay. I felt a charging vibrate, gave me a little zzz. Hello, I press home. Enter my top secret password. Now, I already know that this is going to hang up on iCloud activation. I just want to make sure it's iCloud activation and it's not going to say can't obtain activation data or something stupid. It should come back and hold me back at iCloud. And there we are. So, guys, that is actually where I'm going to stop on this. This phone has been restored. From this point, it is actually, I'm going to need some input from the customer to be able to get past that. But basically, I've taken a known good 128 gig NAND from an iPhone 7, I've erased it, and I've put the low-level system config data from this red iPhone 7 Plus onto it, and then put that chip on the board. It's really not that complicated. It's more tedious than anything. And I gotta tell you, if I was trying to do this with only a razor blade and not some of these fancy tools that are made for doing this, it would suck so bad. I would have I have had deep gouges and scrapes all over the board and stuff. These things do a really, really clean job. So that is going to be the end of this video. I have repaired this iPhone 7 Plus, provided it don't have any stupid problems, and I will see you next time. If you like the video, please click the thumbs up button. If you don't like the video, click that thumbs down button. If you're new here and you like this type of video, I try to post as often as I can, so I would appreciate it if you subscribe. And also, all the tools that I use are linked below. And I will see you next time. Have a good day, everybody. Thanks for watching.